So this is Introduction to Plane Astronomy for the use of colleges and schools by Philip Thomas Maine, et cetera, 1868. Now, this is 1868. We are 2022. Now look at point 4, and this is his proof that we live on a sphere. Now this is quite amazing to me. So point 4, here we go. And feel free to interrupt and answer each one as we go through because there's just 5 of them. So here's 5 reasons why we're on a sphere in 1868. Assuming the Earth to be approximately spherical, we should expect to meet with phenomena which are explained by this supposition and are incompatible with the supposition of its being a plane. Such phenomena abound. Among the most striking are the following. I'll pause there for a minute. What say you of that first underlined?
I take it all back. You continue. Yeah. Okay. I get it. In order for us to assume that we're on a sphere, taking this logic, that is going to be the assumption that we're on a sphere. But to assume we're on a sphere, we've got to go through this process. Here we go. Okay. I'll take it back.
Okay, well, I just want to focus on that first beginning statement because what he's saying here, assuming the Earth to be approximately spherical, we should expect to meet with phenomena. Well, that's what we're saying. We're saying, look, if the Earth is spherical with a radius of 3959, I want to see Earth curve. That's the phenomena. He's saying we should expect to see phenomena, which are explained by this supposition. And then he turns around with the and, are incompatible with the another supposition of its being a plane. Now, this is ironic because they use 3 planes. They use the rational horizon, they use the sensible horizon, and they use the visual horizon. So here they are using 3 planes, and he's saying this sentence. This falls apart immediately if you understand what we've dug up on them. Now, to the average reader, this is going to be, oh, yeah, this makes sense. No, it doesn't, because such phenomena abound. Really, for the globe, this phenomena of us being spherical, the proofs abound. Among the most striking are the following. Here's the first. I want you to answer each one as I go through it. The appearance of the offing at the sea as a well-defined circular line. Now, the offing at the sea, which I've shown and we've seen, is if you're in the middle of the ocean and you're on a boat and you turn around 360, you see a full circle like a cone, and you being above the ocean, kind of like a cone look. They're saying that's curvature.
So we only have one horizon, and the horizon in the question proof of nothing perspective hijacking Earth curve calculator is Earth curve in Muppet Vision perspective omitting Muppet Vision. So no, the horizon is not Earth curve because if the Earth was a sphere with a radius of 3959, then every distance to horizon could be no more than 1.2 times the square root of the observer's height in feet, and the black swan shows demonstrably that the horizon is beyond the limitations of a sphere Earth radius 3959. Therefore, the horizon is not Earth curve. So no.
Yeah, good answer, because the offing is the horizon. And I want John to answer number 2. The observed increase of the dip of the horizon with the height of the observer above the Earth's surface.
Right, that's a differential between 2 planes, the sea level and your eye level, depending on altitude. That offing one isn't the horizon horizontal? How can it be? Never mind. I'll let you finish them off, Tim, and then I'll go back to that.
Yeah. Well, the offing is basically as far as you could see where the horizon is. And it's flat because you've described what dip is precisely the way you do dip. You're absolutely right. Number 3. Oh, this is good. The manner of disappearance of a ship as it recedes from sight. At first, the apparent size of each part gets smaller and smaller. Oh, really? Sounds like perspective. This goes on till the ship reaches the offing, the horizon. After this, the hull is observed to disappear bit by bit from the lowest to the highest part as it becomes gradually hidden by the sea. In this manner, the hull gradually disappears till none of it is seen while the sails and the masts are still visible. Sounds like all the other bricks on top of the first brick. The sails then disappear in the same gradual manner and leave the top mast alone, visible above the water. This then appears to sink a bit by bit, and finally to vanish altogether. Nathan?
So in practical example, you buy a zoom camera with a bigger range and you can bring that hull back because it's down to an optical limitation, which you can calculate with the Rayleigh criterion. Further to that, if I give it in an example, if I were to put a brick on the horizon at a mile, there's a good chance that you could see the brick. If I move that brick to 3 miles, there's a good chance that the brick becomes too small to see and vanishes into the horizon. If I then build a 100-story skyscraper on top of the first brick, that does not bring back the first brick. The first brick is still invisible, i.e. still too small to see at the limitation at the deck due to its limited size. Ergo, at 5 miles, you're missing 1 brick due to the angular limitation and not because there's a physical geometric sphere edge horizon getting in the way. If there was, it would be at 1.2 times the square root of the observer's height in feet as declared in the Earth curve mathematics. However, the distance to the horizon in the black swan is beyond the limitations laid down in the Earth curve mathematics, aka 1.2 times the square root of the observer's height in feet. So as before, the horizon is not Earth curve.
Yes, and did you notice we got them here on orthographic? Let me read it. The manner of disappearance of a ship as it recedes from sight. At first, now all Earth curve math does leave this out. At first, the apparent size of each part gets smaller and smaller. Is that perspective?
Yes, that's angular size.
He's telling you what's happening. Oh, well,
It gets smaller and smaller and smaller until it disappears behind Earth curve. No, it just gets smaller and smaller and smaller until it disappears with perspective. Hull first, because that's where the most limited angle resides, against the deck. You can widen your angle to the sky as wide as you like. Hence, there is no limitation to the angle to the sails. However, the limitation to the deck is an angular limitation. Ergo, perspective will cause the brick to disappear at 5 miles because it's too small, but not the building built on top of it. That's an angular limitation, nothing to do with Earth curve.
Excellent, excellent. Very optical. All right, number 4. The apparent positions of the pole star and the constellations vary when seen from different points on the Earth, precisely in the way in which they must appear to vary if these points all lie on the surface of a globe.
You'll need a flat Earth to measure that angular relationship, because that's what they're being described as. So you'll need a flat Earth to make that assertion. Furthermore, you'll need a Haversine formula to imply that the tool and its arc is actually the concave surface you're looking up at when measuring from the centre of said presupposed spherical Earth that you're in the middle of, and measure out from that centre of a presupposed spherical Earth out through the arc of the tool, now the surface of the Earth you're not standing on, out to the celestial sphere around a single position. Like John described earlier, like in Minority Report, when he grabs a little piece of data with his gloves and throws it out all around him. It's single point at the centre of a sphere Earth, the only point you can get an angle with a flat plane moving out from your position. So no, these measurements aren't facilitated on a sphere Earth because you can't get an elevation angle measurement from a curve.
All right, but do you see the hidden reference to R, and it's because of Earth curve that he doesn't say? Let me read it again. The apparent positions of the pole star and the constellations vary. Okay, so high in the sky, mid-height, at the horizon, they vary. When seen from different points on the Earth, precisely in the way in which they must appear to vary if these points all lie on the surface of a globe. He doesn't say why, but he's trying to tell you Earth curve gets in the way.
Gotcha. So it's begging the question, is assuming the Earth as a sphere with you moving around the protractor of the angle measurement that you take in order for his quote-unquote height adjustments to be in effect.
But you caught it. What kind of measurements did he take?
That description of the heights changing is elevation angle.
Uh-oh.
You need a flat Earth for that.
Problem. Yeah, okay, last one. The shadow cast by the Earth on the moon in a lunar eclipse is always bounded by the portion of a circle.
One more time.
The shadow cast by the Earth on the moon in a lunar eclipse is always bounded by a portion of a circle. So basically, the little curved shadow on the moon there, saying that proves that the Earth is a ball.
Don't answer this one. Hold on. Don't answer this one. Let the Globers have faith that that's still a shadow.
Yeah, but it's very important since we're recording this. What's that one video? And it's a term I keep forgetting where the shadow is the opposite way. If Earth was in the way.
You're talking
Selenellan.
Yeah, I was about to say you're talking about the Seleninian, where you've got sun and moon above the horizon at the same time, and in the most recent filmed one, which was about 8 years ago now, they had the quote-unquote shadow, i.e. it turning red, going the opposite direction.
How does that work?
Well, it doesn't. But furthermore, for their assertion, don't they need convergent light? I.e. the light from the sun goes to the moon and then converges and then carries on past the moon in an orthographic representation to create the shadow, as opposed to
we got a problem now. Their light rays, their light is no longer parallel, which means celestial navigation cannot work unless light is assumed to be parallel, because you need a corresponding angle back from that plane that you use at the center of the Earth, the great circle cut in half, to where you have equatorial plane. That angle must also work with the angle, with that tangent plane that you have to draw on the assumed sphere, or else you can't get an elevation angle. So you need to bring your flat plane with you wherever you sail and have a section in your hand. Yeah, they're in a bit of a problem when the sun cannot cast out parallel light for the eclipses, but must for celestial navigation to work. If you're going to say, allow me the luxury of drawing a rational plane, a sensible plane, and the actual horizon, and let me have corresponding angles as long as light comes in parallel. Then I can make it work on a piece of paper from a sphere.
Until you mention eclipses and then the light doesn't come in parallel anymore.
Oh, shucks. Well, that's all he put.
That's all she wrote.